Okay, so our first property, when you multiply the same base, you're going to add the exponents. And this is why. I'm going to make a simpler problem, though. So let's say we just had x squared times x cubed. What does that really mean? Well, a power really just means repeated multiplication. So x squared really just means x times x. That's what x squared is. What x cubed is x times x times x, right? So if we multiply both of those, how many x's are there? 1, 2, 3, 4, 5. So the shortcut is when you're multiplying like bases, you really just end up adding your exponents. Now this is why, because this is what this means. But this is what you do. It's our shortcut. So if we had x to the 5th times x to the 7th, we are multiplying. It is the exact same base. So when we do that, we can just add the exponents. And so what do we get here? 12. X to the 12th. Okay? Now, this one has a base of 4. This one has a base of 4. So even though the base is not a variable, we can do the same thing. They have like bases. So 4 plus 7 is 11. Now, if that wouldn't be such a huge number, I could actually multiply it out. Like if I got something at the end that was like 2 to the 3rd, I could simplify that to 8. This is going to be a big number. So let's just leave it as 4 to the 11th. All right, now this has multiple variables. So we have to take one variable at a time. We're going to look at our x's first. So we have a 5 and an 8. So that's 5 plus 8. And then we'll look at our y's. We have a 3 and a 2. Okay, so 3 plus 2 is 5. So this gives us x to the 13th, y to the 5th. Any questions?
No.
All right, so the next one is called power of a power property. All that means is we're taking a power and raising it to a power. So let's talk about what that would look like if we went back to our simple example. Let's say we had x squared, this time raised to the 3rd. What does that mean? That means we have an x squared and another x squared and another x squared. That means there's 3 of them. 1, 2, 3. So what is 2 plus 2 plus 2? 6. Now the shortcut says when we raise a power to a power, all we do is multiply the exponents. This is y, but all we have to do is multiply it. So x to the 3rd raised to the 5th is x to the 15th. And then the next one, two to the 6th raised to the 3rd. So we're going to multiply these exponents. So 6 times 3 is 18. Now this one's actually a little tricky. Because if we look at it, is that negative grouped with the 4? It is inside here, but the 4 is being squared. So really it's like -1 times 4 squared. What happens when we square a negative, guys?
It's positive.
It becomes positive. So this answer is going to end up being positive. So what happens is it makes a positive positive 4 to the 4th. A positive 4 to the 4th. Now we actually can simplify this. 4 to the 4th is 256. That's not a huge number. We could. All right, so this kind of leads us into this. Because anytime we have multiple parts to our expression, each part has to be raised to that power. So on this one, the x squared has to be cubed and the y cubed has to be cubed. So everything in here has to be raised to this power. So when I have a power raised to a power, I multiply them. So 2 times 3 is 6. And 3 times 3 is 9. Okay, now this one has 1, 2, 3 parts in here being raised to the 7th. So the 2 has to be raised to the 7th. The x has to be raised to the 7th. And the y to the 6th has to be raised to the 7th. What is y to the 6th raised to the 7th? 42. 42. Y to the 42nd. We're not used to seeing huge exponents. You don't normally see ones that big. Now, 2 to the 7th is something we can actually do. 2 to the 1st is 2, 4, 8, 16, 32, 64, 128. I was just doubling. So 2 to the 7th could be simplified to 128. It's not a giant number. Now, if we did this on a test or a quiz, I'd give you like 2 to the 3rd. Something smaller. All right, now this is where it starts mixing it up. So this one has to be raised to the 3rd, and that's pretty simple because they were both to the 1st power. And then this one has to be squared. So what does this make? Z to the 10th. All right, so let's turn it over to the back. And I want you to try some of these. I'm going to mix them up. But I'm just going to do the first 3 sections. So, I'm not going to give you them in order though. If you're not sure what to do, I want you to make sure you ask me. I'm going to hit pause on the recording so nobody can hear you ask a question. Okay, so the first one was probably the hardest one. Everything in this expression has to be cubed. So the 2 has to be cubed. The A is cubed. And the B squared gets cubed. So that makes B to the 6th. Now, this one's simple enough. 2 cubed. We could simplify this to 8. On this one, we're straight out multiplying. So the 2 doesn't have anything to multiply by, so it's just 2. And x squared times x to the 4th is x to the 6th. When you're multiplying like bases, you add the exponents. This one, we're raising a power to a power, so we multiply. This one, we're multiplying, so we add. Any questions? You good? Okay. Okay. So now let's take a look at division, which I never think of as division. Now when you multiply like bases, you add the exponents. When you divide, you subtract them. But I really like to think of this as canceling. Because if I can think of it as canceling instead of subtracting, then what happens is my variables end up staying where they need to be. And I don't end up with negative exponents. So let me show you what I mean. What I mean by this problem is x to the 5th over x cubed. Don't write this down, but it means x times x times x times x times x over x times x times x. So those cancel, those cancel, those cancel. We're left with 2 x's. We're left with x times x. And what is x times x? X squared, that's right. So what we can do is if we subtracted them, we would get x squared. 5 minus 3 is x squared. But I like to think of it like this. 3 of these cancel with 3 of those and leave us 2. And it leaves us 2 in the numerator. Okay, it's going to help us on this problem if we think of it as canceling. Now, here I have 1 3. Here I have how many 3's? 2. So one of these is going to cancel out with one of those and just leave 1. And then here I have x squared over x to the 5th. If I subtracted, I would end up with a negative exponent. And we never leave negative exponents in our answer. So if we think of it as canceling, 2 of those cancel with 2 of those and leave us 3. It actually leaves it where we need it. It leaves x cubed in the denominator. We had a 3 left in the numerator and an x cubed in the denominator. Now let's cancel our y's. This means we have 4 y's. This means we have 2 of them. So 2 of those will cancel with 2 of those and leave 2. So it leaves us a y squared in the numerator. And that's our answer.
Wait, so why does the bottom 3 cross out and the top one doesn't? Like, why do you write the 3 up?
Okay, because up here we had 2. So here we have 1 3. So this 1 cancels with one of those and leaves 1.
Oh, okay.
Okay, so on this one, we have x squared over x. So this 1 is going to cancel with one of those. And then we have y to the 7th over y to the 10th. So 7 of these cancel with 7 of those and leave how many? 3. All right, so we're left with an x in the numerator, but just one of them, and y cubed in the denominator. What happens if everything in the numerator cancels out? What is left? An understood 1, so we have to put the 1 there. Good. Okay, so this is mixing it up again. A little bit of both, a little bit of both, a little bit of both. So we've got the division. Well, nothing cancels on this one, so we can go ahead and cube everything. So everything in the numerator gets cubed and everything in the denominator gets cubed. So 2 squared, x squared is cubed and makes x to the what power? 6. Power to a power, you multiply. And then in the denominator, the 5 also is cubed. What? Do you remember what 5 cubed is? 125. So it's x to the 6th over 125. Okay, so I'm going to write the cubes over here just to remind us 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Wasn't 6 the largest one we did? 216? That's the largest one we did earlier this year. Okay. All right, so in this one, everything has to be raised to the 4th power. So the a cubed has to be raised to the 4th. What does that make? A to the 12th. The b squared has to be raised to the 4th, so that gives us b to the
8th.
And that's it. Now the third one's more interesting. When I work a problem and it's got a lot of stuff going on, like number 15 does, I always try to make the inside as simple as possible before I deal with any exponents on the outside. And this does simplify. Do we see that 5 of these will cancel with 5 of those and leave us how many? 2. So we got an x squared. And then this one will cancel with 1 of those and leave me 2. So really, that quotient simplifies to just x squared times y squared. And then I would cube it. I wouldn't cube everything first. I simplify the inside first, and then I do the power. So simplify first. Then do the power. So now I get x squared that's cubed, so that's x to the 6th. Y squared that's cubed, so it's y to the 6th. And that's my answer. Okay, so before we do the negative ones, I want to do some more. So this is going to mix it all together. All right, let's say we had 2x squared y over x to the 5th squared. That's good enough. Number 3 is a doozy. the first two were sort of straightforward. The last one was pretty tricky. So let's go ahead and take a look at these. So number 1, which could be number 5 if you were numbering the other way. Did y'all number it that way? All right, so 1 or 5, it doesn't matter. All right, so on this one, we would say these two cancel with 2 of those and leave us 3. So this is what we have left to square. So we have a 2 and a y over an x cubed that gets squared. So we simplify the inside, then we deal with the power. So the 2 gets squared and gives us 4. The y is squared, and the x cubed gets squared and gives us x to the 6th. All right, any questions on this problem, whether you numbered it 1 or 5? Okay, now this one, all we have to do is simplify what's on the inside. So, I'm going to do it in different colors. We start with the numbers. So we treat numbers like we always have. 4 goes into 4 one time, 4 goes into 8, 2. Now I'm going to do the A's. These 3 cancel with 3 of those and leave 2. Now I'm going to do the B's. That's a pretty color. All right, so these 2 cancel with 2 of those and leave 2. It's pretty, but it's hard to see. Switch back. All right, so what are we left with? In the numerator, we have an a squared and a c. In the denominator, we have a 2 and a b squared. Make sense? All right, so this is, I'm just going to rewrite the problem. All right, so let's start simplifying the inside. This A cancels with 1 of those and leaves 2. This B cancels with 1 of those and leaves us 4. And then 2 of these C's cancel with 2 of those and just leaves us 1. So we have a negative A squared over a b to the 4th c. And now we can square it. So what happens when you square a negative? It becomes positive. And then a to the 2nd raised to the 2nd becomes a to the 4th. b to the 4th raised to the 2nd becomes b to the 8th, and then c squared. All right, now let's work on the second part. On the second part, all this stuff has to be cubed. So the 2 gets cubed, the a is cubed, and the b squared gets cubed. So when I bring this down here, it's hard to tell what we do because this one's written as a fraction, but this one's not a fraction. What do you think?
You forgot to put squared by c.
I did. Thank you. You are right. All right. So since this one's a fraction, if we just put this one over 1, now we see that they're both fractions. And remember when we multiplied fractions last semester? Anything in a numerator can cancel with anything in a denominator. Because what this really means is all this stuff is in the numerator. And all of this is the denominator. So anything in a numerator with anything in a denominator. Well, I see that we have 6 b's right here, and we have an 8 right there. So those can cancel and leave a b squared. And now, if I look at my numerator, do you see I have an a to the 4th and an a to the 3rd? So that makes an 8 a to the 7th over b squared c squared.
So we have to do this like whole thing, like when we, or can we stop like
This
when we get
is
to-
this is the final
Oh,
answer.
okay.
Yep, that's what we'd be looking for. All right, so this would be like the hardest type problem. Okay, now the last thing we're going to look at, negative exponents, and I didn't put it on here, but we're going to talk about 0 also. I almost got it all. Y'all can kind of read that. So, with a negative exponent, we need to think reciprocal. With a negative exponent, you think reciprocal. So 5 to the negative 3rd is really 1 over 5 to the 3rd. We do the reciprocal. So this becomes 1 over, what is 5 to the 3rd?
125.
125. Okay, now what happens if we have a negative exponent that's already in a fraction? Instead of doing reciprocal, we just take anything that's to a negative exponent and move it. So let's say we had 2x squared b to the negative 3rd over c. So any part of the expression that's raised to a negative exponent moves. So this would become 2x squared over b to the positive 3rd c. So when you move it, it becomes positive. So now on this one, both of these are negative.
So do you flip
So you gotta move both of them. So you really end up flipping the whole thing. Because this one's negative, it moves down here, and because that one's negative, it moves up there. So we're left with x squared over x to the 5th, which will simplify, won't it? Okay, so we can say 2 of these x's cancel with 2 of those and leave 3. What's understood in the numerator that we have to write now? A 1. So this is 1 over x cubed. Now, this one is different than this one. On this expression, we had one variable that was raised to a negative 1. On this one, the entire expression is raised to a negative exponent. But I still do the same thing. If it's a big expression, I try to simplify, make everything easy on the inside first. So what I would do on this problem is, I would start by saying, okay, one of these 3's, this 1 3 cancels with one of those. 2 of these x's cancel with 2 of those. So what I'm really left with is 1 over 3x cubed. So now this entire expression is raised to a negative exponent, which means we flip the entire thing. It becomes 3x cubed over 1 squared. So when you flip it, it goes from a negative 2 to a positive 2. Now, do I have to write it as over 1? If the denominator is 1, do we have to have it? No. So then we just square all this stuff and we get 9, because 3 squared is 9. And then we have x to the 3rd squared. So 3 times 2 is 6. Yes, sir.
If it, could anything just flip out the very beginning?
Yes, you could have. All right, so that is it for our lesson.